next thing we're talking about is tree ring sampling. I'm not familiar with this. We do increment cores. These are non-destructive. It's just you screw into the tree and you get out this core, and you just, the tree is not hurt. And you can have 12 millimeter cores that give you more sample to do isotope work, or smaller ones. Or you can use the old chainsaw and get the cross section. I'll show you some of the reasons for that. You can get them from trees, obviously, or you can get them from historical buildings, bridges, fences, archaeological wood. There's wood right there from thousands of years ago. Alluvial deposit, there's some wood right there. Bog deposits, pack rat mittens, there's all kinds of things that you can get cellulose records from. But that's where you get them from. In terms of isotope variation, one of the first things you need to do is understand the variation within trees and between trees. So here's just the circumference of this tree, and you take a bunch of different radii, and you look at the carbon isotopes variation. So what you can see here is it doesn't particularly matter which radii you use. They're giving you the similar relationship. Here's another one for what they had is a very oddly shaped tree, and they thought, well, what if we take the core from there versus there? Are we going to get different isotope numbers? Well, you can see pretty much not. This is carbon, that's deuterium. The oxygen is just spot on. So around the tree, there's not as much variation as you would think about. The next question you have to ask is variation between trees at the same site. And what we call this is coherence. How coherent is the signals for the same trees in the same site? And if you look at oxygen, this is some of my work at Jedediah Smith, the oxygen is pretty good. All those trees are responding to, and what we mean by coherence is if all the trees respond the same way, then they are responding to a common environmental signal. If they're going every which way, just give up. Because there's no way that they're all responding to a common environmental signal if they're not coherent. Does that make sense? Okay, so you need to make sure that you have that coherence. Now, what's interesting is this is for oxygen. For carbon, it's a little messier, but the values are still reasonable. All the trees are responding in the same pattern, but each individual tree can be quite different. The absolute value for the carbon isotope can be quite different, even though they're all doing the same pattern. Following me? Why? The carbon isotope is much more sensitive to position of the tree. It's in the shade, it's in the sun, other kind of physiological processes. Oxygen doesn't seem to be that sensitive to those kinds of positional changes. Okay? So this is a good paper by Steve Levitt that talks about variation within trees and between trees for the three major isotopes we're going to talk about. If you're interested, read that paper. Okay. This slide is everything you should never do in PowerPoint, right here. This is the worst PowerPoint slide ever, okay? But I haven't changed it for one fundamental reason. There's a lot of information here about cellulose purification. Do not worry about all those words. Just forget them, okay? This is not, what do I need to know for the exam, professor, type of thing, right? Why I put all this stuff up here is this. I view your notes as a resource. You should keep those things. And maybe 5 years from now, you say, I want to do cellulose extractions. And that Dr. Roden talked about cellulose extractions in IsoCamp. You go to this page, and there it is. And there are all the citations you need. You have those citations, off you go. But right now, don't worry about them, okay? What I really want you to get out of this particular slide is one thing. Why do we extract cellulose? What is the purpose and why? And I'm going to blow up this thing because it's kind of small. But this is deuterium content in raw wood, lipids and resins, cellulose, hemicellulose, and lignin. First thing you should note is they're different, right? They're not all the same isotopically. And the question becomes, is if you go from 1 year to the next in the tree ring and you get a change in the deuterium content, is it because of a climate change from 1 year to the next, or because the ratio of these things switched? You following me? So you need to know that that's shit. Now that might seem a little bit trivial. Some things, lignin and cellulose is a pretty common thing, but there can be differences in lignin and cellulose. But one of the big things is this guy, resins. How many of you know what heartwood is? Heartwood is full of resins, and you get past the heartwood to the sapwood, you've made a massive change in this component that has nothing to do with climate, right? So what we really want to do is get to a common feature that is stable, is stuck in the tree ring. The other thing you need to know is this. Resins are not fixed. They are mobile. In other words, they move through the tree. So that particular resin in your tree ring may not be from when that tree ring was made. It might have been from 5 years earlier or 5 years. It doesn't matter. They move. And so really you should get rid of them because they're not telling you anything about that system. Do you understand now? So this is one of the reasons why we extract to cellulose. It's abundant and it's fixed.
Can I just add something to that? For people that work on animals, lipid extraction is a big thing for tissues. People who take things. Lipid extraction, this is the same reason you do lipid extraction, because sample to sample, the amount of lipids in your sample might change, and thus your isotope value is going to change too. So it's the same strategy, the same idea behind it.
Yeah. Why are lipids so big?
Well, you'll see. I mean, there's a lot of reasons for each of these. I'll show you where they are, and they come through glycolysis and other things. Okay? You guys are ahead of me. You're just getting ahead of me. Go ahead, it's fine.
This might be a little bit off topic, but if you're looking at water samples that you extracted on the extraction line, and you have some of those resins in there, and then you're getting some of the deuterium and oxygen from those lipids, and being that they're mobile, do you have to incorporate that as skewing your results?
Well, one thing, you better not run them on the Picaro.
Yeah. Well, definitely not run on the Picaro, but if you're looking at, say, like with the 2 water volts, if you're looking for a water source for these trees, do you have to consider that? If you have really resin water samples?
You probably would do a charcoal extraction. You try to get rid of them, but you would have to consider it if it's high. Most of the time, they're low enough that you don't worry about it. But if you have your water sample and you can smell it, you know what a pine smells like? Yeah, you better do something with it because it could affect your numbers. Okay. All right, so there's also been a number of things about people saying, but I really want to just do whole wood. Cellulose extractions take forever. And, by the way, they don't take forever because they're batch processed, but there's another reason. But some people have said, look, this is the whole wood oxygen isotope variation. There's the cellulose, and they have pretty much the same patterns. Oh, this one's going up and that one's going down. There's about a 5 per mil offset, but there's some variation. If you're okay with that variation, but sometimes I'm not so comfortable with it. If you're doing carbon, however, this is some work I did with Graham Farquhar a few years ago, in that this is 2 different species, a gymnosperm and angiosperm, and this is cellulose and whole wood, and the slope is 1 for both of them, and it's a nice tight relationship. If you want to do whole wood on carbon isotopes, I'm okay with that. That works. You still might want to resin extract it. But, that's not bad. But for oxygen, the slopes are not really 1. There's a lot of scatter. The species are different. I'm not comfortable yet with doing whole wood on oxygen. And there's reasons for that. Okay, but people are debating this. Some other techniques, oftentimes we take tree rings and we cut them out with a razor blade, but we now have laser ablation techniques. I think Terry will talk a little bit about these, where you can get lots of intensive measurements. This is really only valuable at this point for carbon isotopes. It doesn't work for oxygen, and there's reasons for that, which we can go into if you want. But laser ablation is being used. We have in my lab a robotically controlled micromill where you can get out micron levels of tree ring stuff. So there's other ways of getting the tree ring out. That's just sort of basics I wanted to highlight. Okay, other questions?